Okay, what is the array? Array must use a data structure in computer programming, and array stores the group of elements, and that elements is located sequentially, and also that elements are the same data type. And if you're going to store a list of integer numbers, and you cannot store these integer numbers in a string, okay? Your data type must be same. Arrays in different program language are as we have a static and dynamic, and we have a static array and dynamic array. In Java and C++, we have a static array, and in Python and JavaScript we have a dynamic arrays. And what is the difference between a dynamic and a static arrays? Okay, and static arrays are fixed size. Whenever we are defining the array and we are creating the array, we must define the size of the array. If you're going to store 10 integer numbers, before you are creating your arrays, you must define the size, which is the 10 or 11. And if you are defining the 9, you cannot store 10 integer numbers inside your array, okay? And on the other hand, we have a dynamic arrays, and in dynamic arrays in Python and JavaScript, we are not during the creation, defining the array, we are not define the size of the array, and during the runtime, and their size is automatically grow and shrink. Okay, next we have one-dimensional array and multi-dimensional arrays. And one-dimensional array are we have one rows and multiple columns. And I have a list of numbers inside my array, and which is 1, 2, 3, 4, and 5. And I have one row and multiple columns, and my columns can be n. Yes, it can be the 100 million. It doesn't. We are not. This is a infinitive. Okay, and rows. But rows is only one we have. This is the one-dimensional arrays, and we have index numbers, which is starts from 0, 1, 2, 3, and 4. And this is for accessing any given numbers from the one-dimensional arrays. We have an array, and if I'm gonna access the 3, I'm gonna just write the index, which is 2, it returns me the 3. Okay, and also if you are gonna access the last of the array, which is the 5, okay, and I'm just gonna write array, and it is the 4. Okay, like this, it returns me the 5. Okay, we have and the next type of arrays, we have multi-dimensional arrays. Okay, and these are arrays, and we'll start from the two-dimensional arrays, which is the one-dimensional arrays, and we have a two-dimensional. Okay, this is the two-dimensional arrays, and we have multiple columns and multiple rows. Okay, and for accessing any given numbers from the two-dimensional arrays, we'll be gonna write like this. I'm gonna access the 10 numbers, and for accessing, I'm gonna write array. And first of all, I'm going to write what is the rows, and inside we have a 1, 0, 1, and 2, and 0, 1, 2, 3, and 4. And first of all, I'm going to look at the rows. At the 10 is located as a 1, which is the 1, and after that I'm going to look at the columns index, which is the 4. Okay, and this returns me the 10. Okay, so we'll see one more. If I'm going to access 13 array. And first of all, we're going to write the rows, which is 2, and then I'm going to look at the columns, which is 2 and 2. Okay, and this is how we can access any given numbers from the two-dimensional arrays. This is the 3D dimensional arrays, and we are writing like this, but we are using rarely. Okay, and we are not using too much from the 3D dimensional arrays. And let's see how we can access any given number from the 3D dimensional arrays. If you're going to access the 4 numbers from these 3D dimensional arrays, firstly, we'll be going to look at here first, and which is the array. And first we're going to look at the here, which is the 1, which is located 4, is the 1, and which is 0. Yes, 0 and 1. And the next one, we'll be going to look at the here at the top, which is the 0 and 0. And then I'm going to look at the here of index of here, which is the 1. This returns me the 4. Okay, and we'll see the one more time, which is the 3. I'm going to see that this one is 3. Okay, for accessing 3, and firstly I'm going to write, which is the 1. Okay, which is this is the one side. Therefore I'm going to access the 1, And after that, and the first and the up down, I'm going to look at the rows and what is the index, which is the 1, and then I will look at here, which is this is 0, like this. But 3D-dimensional arrays we are using rarely, and especially we're going to use the one-dimensional arrays most, and the two-dimensional arrays. And two-dimensional arrays we are using if you are going to be a machine learning engineer for the 3D-dimensional arrays. We are using whenever we are going to create matrices. Yes, we'll be going to use it two-dimensional arrays. Okay, and 3D-dimensional arrays rarely, and especially we are not using too much. Okay. Okay, next, we'll see how one-dimensional array represent on the memory. Okay, I have one-dimensional array. 1 and 2, 3, 4, and 5. And I have a memory, a computer memory. Every cells here is a 4 bytes, okay? Every numbers requires the 4 bytes for storing on our computer memory, okay? And here, we have firstly, and we have indexes, yes? And in the memory, especially, we have addresses for all given numbers. For example, for storing this, these arrays are located and represented on the memory sequential, okay? Which are, for example, looks like this: 1, 2, 3, 4, and 5. They are sequential, turn by turn. And the addresses, for example, the first index, this is first our numbers, which is the indexes, and addresses. If we'll take the 100, the next address of numbers will be 104, because we have 4 bytes. Yes, therefore the addresses will be the +4 and +4 and +4, and like this: 8, 12, and 16, and like this. Okay, and we have a formula for any given, finding the addresses for any given numbers. Okay, and I'm going to find the 4 of index, and I'm going to find address of 4 for finding, and I'm going to use first of all, we have this is the first indexes, which is the first address. We have a first number and we have a first address, which is, I'm going to take this and I'm going to plus, and I'm going to multiply which is the size of every cells, where we have a 4, and then after that I'm going to multiply to this index of that number, which is the given number, which is the 4 I'm going to find in case, and which is the 3, and it will be 112, which is we have a 12. Okay, and this is how a one-dimensional array represent on the memory. Okay, we're going to see how two-dimensional array represent on the memory. We have a two-dimensional arrays, and we have a memory. The every cells is 4 bytes here, and these numbers also represented on the memory sequential, like this: 1, 2, 3, 4, and then we have a 12, 11, and 10, like this. Okay, and sequential, and these are also the same, which is how one-dimensional array represented, and this is also the same, which is the sequential. And the three-dimensional arrays also represent on the memory sequential, okay, turn by turn. It looks like this. Okay, next, we're going to see how what is the time and space complexity of one-dimensional arrays. Okay, I have a given n number of integer numbers, which starts from 1, 2, 3, and goes n-1 and n, which is the given n integer numbers inside my arrays. And first we'll define the time and space complexity for this array, one-dimensional arrays, and time complexity and space complexity. And for creating these arrays, the time complexity requires constant time, which is the O1. The space complexity, which is the linear time complexity, which is the On. Okay, we have n integer numbers for creating time complexity. Space complexity requires n. And okay, for removing the last of value, yes, last of numbers. The time complexity requires constant time, and the space complexity also, we don't need extra space, constant time. And also for deleting from the middle or the first, we need the time complexity, which is the linear time, which is O(n). Why? And you may asking, I'm going to delete the 1 here, from here 1, yes. If I delete 1, all numbers will be moved to the left, okay? 2 will be here, and 1, 2, and 3 here, and all's like this, okay? For they are changing their places, their indexes. This is requires O(n), which is the n. Therefore, the time complexity, which is the O(n), and space complexity, we don't need extra space, which is time complexity constant. And also, for searching any given numbers, the time complexity also require O(n). Okay, we are iterating, yes, iterating. For example, I need any given numbers. I don't need the n, which is the last number, or I need the middle of numbers. I need to search any given numbers. The time complexity, which is the O(n). The space complexity, we don't need extra space, which is the constant O(1). Okay, and adding, we're gonna inserting the numbers to these arrays, and inserting for the last, we need the time complexity. This requires that constant time. We don't, because we are adding at the last. We don't need too much time, yes, for this. And also the kind of time complexity will be constant time. Okay, for inserting the any middle or the first, yes, the first or middle, we need the linear time complexity, because if I'm going to add from here to 0, yes, I'm going to add a 0 here, all numbers move to the left, right, yes, which is all numbers move to the left, okay, like this. And we're going to insert 0 from the 0 index, okay. Therefore, for this, time complexity as a linear time complexity, which is O(n), and the space complexity, we don't need extra space, which is O(1). Okay, this is the time and space complexity of one-dimensional arrays. Okay, we'll see how two-dimensional arrays and time and space complexity. Okay, and firstly, this is, and I'm gonna, we can, this is the columns can be the m, okay, which is first. Columns can be m, which is that we have a infinitive maybe, and rows also can be n, which is the n. Yes, we don't. In this case, we have n is equal to n is equal to 3. Yes, and m equal to 4. Okay, and n can be we have a different in this time, but we have a n and m. Okay, and for this we'll see how the creation whenever we are creating the two-dimensional array, and the time complexity, which is the O(1). Okay, and the space complexity is required, which is m n. Okay, this is, and if, for example, and we are going to create, and n is equal to 3 and m also equal to 3, in this case our space complexity will be quadratic time, which is the O(n) power of 2. Okay, and for deleting from the last array, yes, from the last, we need the constant time complexity, and also which is we don't need extra space, which is the O(1). And for deleting from the middle, from the first, the time complexity, which is n m. Okay, and also space complexity will be constant. Okay, and for iterating these arrays, and for iterating and finding any given numbers from the two-dimensional arrays, which are the time complexity will be n m. And also space complexity, we don't need extra space, which is extra constant time. And also for adding to the last, we don't need for adding the inserting to the last time complexity, which is constant time, and space complexity also constant time. The inserting from the middle to the middle or to the first, the time complexity will be nm, and the space complexity is constant. Okay, and this is how the space and the time complexity for the two-dimensional arrays. Okay, let's jump into the VS Code and we'll create arrays. Okay, for creating array, I'm going to use NumPy library, and in the Python we don't have array built in data structure. Instead we have a list, but we are going to create array. Therefore I'm going to use numpy library. Okay, and for using numpy library you need to install numpy using pip install numpy. Okay, and after that you need to import inside your code. Okay, and firstly I'm going to create the file which is array.py, and in here firstly we need to import our numpy library. After you install, I have already installed it. If you didn't install, you should install, and after that import it. Okay, at the top import numpy and as np. Okay, and then we're going to create our first array, and my array is equal to now np dot, and you see extension shows us what we can do with numpy. Okay, and here we're gonna create an array. Therefore we need to write array, and after that inside a parenthesis we need to give the argument what their requirement. You see here the first is requirement is the object. Okay, and we need to write a list of what you can store inside array, and you need to store the same data type. Okay, and we cannot store, as I told, we cannot store different data type. Okay, therefore I'm going to store integer numbers, and 1 2 3 and 4. Okay, and after that the comma, and you see here is the extension. It shows us that what is the data type of this array, and I'm going to write is inside a quote integer. Okay, I'm going to store integer in this array, and after that we're going to print this array on the terminal. Okay, my array, and so open terminal in Python array.py, and you see here is it's printed. It's actually created our array, and let's look at here. And whenever we are creating our array we need to define and what is the type of, but it's not necessary. Okay, if you don't for example, without defining this type of data what we are storing, and during the runtime Python knows what is the type of this, but let's going to print it, and you see it's printed is an integer, but is a big but and if I add some of the string, okay, and for example op, okay, but in this case our arrays, and we cannot store this the different type of data. Therefore but in this case Python will not return error. Instead the numbers converted to the strings. Look at here, and you see here is the 1 is converted to the string, and 3 also, and others are converted. And but if I write after that is inside a quote integer, in this case the Python returns the error. Okay, and let's want to see, and you see there is invalid literal for int. Okay, with base 10. Okay, and this is the returns the error because we defined we need our array must be integer, but we add a int string, it returns error. Okay, and this is for creating string. We need to inside the quotes and with uppercase u. Okay, and this is the string. Okay, and if we write like this, and this is all is converted to the string. Okay, and but we cannot add an integer also. Okay, and also for if you are going to create float numbers, and let's want to create a float numbers. For using the float we need the small f. Okay, and let's want to see, and you see there is the dot which is the float is. Okay, and this is all about how we can create the array. Also we know this is the firstly I explained what is the array, and after that we spoke about the one-dimensional array and two-dimensional array and three-dimensional. For creating one-dimensional array, and this is the one-dimensional array as you know, and this is the linear arrays, which is also one-dimensional arrays. And let's do some operation with this, and here we can insert, we can delete some of the numbers from inside this array. But and you know from if you and we're going to define the list, and li and equal to, and we are storing list of numbers, and whenever we are going to add some of the numbers inside list, we use like this li dot append. Yes, but in NumPy we cannot do it. Instead we need to create a new array and like this, and firstly new array is equal to np dot what we're going to do, we are going to append the numbers inside our arrays, my array. Okay, for this we're going to append. After that we need to write our what we can do, and you see there is the extension shows us what we can do. We are going to add, we can write our array. Okay, and therefore in this case my array, I'm going to append the number to my array, and after that we need to write the values. Okay, and the values is, and or for example is 3. Okay, and after that there is the axis, which is the for this axis is especially whenever we are working with two-dimensional array and three-dimensional array, it helps us to know what is the rows and columns. Okay, but in this case we have one row and multiple columns. Therefore, we don't need to write axis, but in the one-dimensional array. Okay, just write a 3, and after that, let's we're going to print my new array. Let's want to see, and you see here is the float. Okay, and it's going to change int to the, and okay, we successfully add the 3 at the end. For inserting any given numbers to the middle or to the first, we need to write. We're gonna create a new array like this, and the array is array, and the second array which is equal to np dot. We're gonna use the insert function, insert, and after that, and here also we need to what is the array? In this case, we are using the new array, yes, and the new array, or we can write and my array also. We have a 2 array in this time. Okay, my array, and after that here, and we need to write what is the index. Okay, we need to write where we can to add this number. For example, I'm going to add the first at the first. For example, I'm going to add at the first, and the value after that I'm going to add for example a 10. Okay, I'm going to add 10 to the first of the list. Okay, which is the index is 0, and here the value is 10. Okay, and let's want to print it, this array, and array 2, and let's going to see it, and you can see here we are successfully added to the first of our arrays. Okay, and for adding, we can add whatever way we can want. For example, I'm going to add a second index. Yes, as we see, and you see here is after 3 I successfully added our 10 integer numbers. Okay, and this is how we can insert and append and the numbers to the arrays. Alright, let's we're going to iterate how we can iterate our arrays. It's easy, just how we are iterating lists, we are just iterating this also. In this case, I'm going to iterate my array. Let's we're going to for I in my array, and here I'm going to print all my numbers inside the array. Okay, let's going to see. Firstly, I'm going to comment this, and let's print it. You see here is successfully printed all, which is we have first my array is we have 3 now integer numbers, which is 1 and 3 and 4. It is successfully printed. Okay, and this is how we can iterate and how we can work. And here is you may be asking, what is the difference between a list and the array? Okay, and here is one of the big difference. This is the array is faster 50 times faster than list. Okay, and also we can do more operation with arrays. And let's going to create, and here let's create the list. Okay, and the list is equal to, for example, inside a list of numbers, which is 1, and let's going to create 10 and 8 and also 6. And you see here is we have a list of numbers, and also we're going to create the same array here. Okay, and let's change it, and we have the same, and we have you see here is we have a list of numbers and a list of arrays, and you see, and then I'm going to do some more operation with array and list. Let's be first operation what we can do with array and what we cannot do with list. And my array, and we can divide and this for 2. Okay, and it returns me 5, 4 and 3. Look at here, and 5, 4 and 3. Yes, and but in the list we cannot do it. Let's see, and you see it returns the error, and this is some difference between the list and arrays. And okay, we're going to create a two-dimensional arrays, and how we can create two-dimensional arrays, and how we can access, how we can append, and how we can iterate the two-dimensional arrays. Okay, we're going to create our two-dimensional arrays, and my two-dimensional array is equal to np dot array. Inside we have, let's a square bracket and a nested square bracket, and first inside the square bracket we're going to write our numbers, which is 1, 2, and after that and another inside the square bracket we are going to write another list, which is we're going to create a two-dimensional array, like yes, and after that we're going to create, let's see, and also we can define what is the type of this, and inside the quotes I'm going to integer, yes, and let's print it. print my two-dimensional arrays, and let's see. And you see here is I successfully printed two-dimensional arrays. And as we told, the two-dimensional arrays with multiple columns and multiple rows, okay, you will have, and we can create it. And let's see how we can access the two-dimensional arrays. Okay, for accessing, and as we spoke, the whiteboard, firstly we need to write our rows, yes, and let's we're going to access the 3. And the firstly we're going to look at the rows, which is the rows is 1 and 2, and 0 and 1, which is the 1, and after that inside another square bracket we need to look at the columns, which is the columns is 0. Okay, let's we're going to see, and it returns to 3. Okay, how we can access two-dimensional array using this. And also we can append and list, okay, and in numbers to the, for example, I'm going to append at the end for example, we're going to append firstly, and we need to create the new arrays, new 2D, yes, and equal to np dot, I'm going to append, and here we need to write our two-dimensional arrays with all two-dimensional array, my 2D, and after that, and for here add values, which is we are going to add values. In here we need to write like this, is a 2 nested square bracket inside, and for example, and let's 5 and 6, and after that we need to write the axis. What is the axis? Is the axis, and axis is equal to, which is the rows, and after that which is the 0, yes. Let's see how we can append it. Let's want to print it, and print new 2D, and you see here is successfully appended to the at the end of this our arrays. By using the insert function, we can insert this list of numbers to the first or to the middle of our arrays. Okay, we're going to use insert function, and here we're going to change the insert, and then dot insert, and here, and after the array we need to write the index of the where we can add. We are going to add to the first, we need to write 0 and after the columns, and we're going to see and how it's worked. And you see here is successfully added to the first. Okay, and also we can insert to the middle also. I'm going to write 1, and you see here is successfully added to the middle. And this is how two-dimensional arrays we are inserting and adding, and also we can remove it by using remove and delete function. Let's want to delete using the delete function, delete, and here we need to write the index of this, which is the index of, for example, I'm going to delete the first. I'm going to delete the first numbers, which is this 1 and 2. I'm going to delete this arrays. Okay, and these numbers for doing this, we just write this and index, and that's it. Let's see. And you see it's successfully deleted, and 1 and 0, which is nested first our square list, which is this we deleted, and inside only we have 3 and 4, and this is how we can delete it. Okay, we're going to iterate our two-dimensional arrays for using the for loop, and using the for loop I is in my two-dimensional arrays, and here, and our first iteration is iterate on the rows. Okay, our two-dimensional arrays, which is the, let's we want to see is, and which is A. Every rows is what is the first row we have, what is the numbers, and what is the inside. It returns all numbers inside the square bracket. Okay, let's see on the terminal, and you see it returns only 1 and 2 and 3 and 4. For iterating these columns, we need to use the second loop, which is the nested loop, is G is in I. Okay, every I we are iterating and we are printing it. Okay, print using the print function J. Okay, let's see, in this case we are iterating all numbers, which is the 1, 2, 3 and 4. Okay, step by step like this, and this is how we can iterate our two-dimensional arrays.